Welcome to the JavaScript Live webinar. This is part of our live series webinar, webinars that we are hosting at Amicus Recruitment. So my name's Christy O'Brien. If you haven't heard of us before, Amicus Recruitment, we specialize in recruiting for 3 key areas of IT, which are JavaScript, Python, and Golang. Today we're joined by JavaScript expert Richard Silverton, who'll be giving us a talk on TypeScript tips and tricks to help manage a growing code base. So this session will last around 45 minutes with intervals for any questions that you ask. So it's fully interactive, the session. So there's a Q&A tab at the bottom of your screen. So please ask as many questions as you want throughout the webinar, and I'll ask them to Richard. So anyway, that's enough from me. Richard, thanks for joining us. Please feel free to start whenever you're ready and share your screen.
Great, thank you very much. Hopefully everybody can hear me. First of all, apologies, I am just recovering from quite a bad cold, so if I'm a bit husky or I stop and then go quiet for a bit, I'm probably coughing or something. Apologies for that. I will try to get through it as cleanly as possible. Yeah, so thank you very much indeed for the introduction, Kirsty. I've been described as a JavaScript expert, so I hope I can kind of live up to that and give you something interesting in the next few minutes. I want to talk about TypeScript and specifically the things that I feel that we've learned at Reinfer in terms of utilizing TypeScript to help us grow a code base with as little pain as possible. Yeah, I'll kind of take you through some of those. It's not like supposed to be a review of the entire language or anything, just some key things that I think are really important. So I suppose I should just start by introducing the company that I work for, Reinfer. What's the big idea? This is a quote not from me, from somebody who's an expert in machine learning, who says natural language processing has come of age and it's beating humans in language understanding. And what they mean by that is that this GLUE score, which is a generalized language understanding evaluation score, it's basically a bunch of tasks which are not the sort of thing you'd expect a computer to do well at, are designed to measure understanding of language, and the very latest machine learning models, natural language processing models, are actually beating the average human being these days. This is something that I think 10 years ago people expected all fields of machine learning that it would outstrip human beings, and it's been pretty slow at doing that, but not with natural language processing, which really is better than people at doing that job now. So what are we doing with it? We describe ourselves as a conversational data intelligence platform. What that means is, I'm assuming I'm speaking to developers, we make human readable data, so that's stuff like email inboxes or customer review channels, stuff like that. We make it machine readable and with all the right contextual understanding baked in. So we'll let our clients train models without needing any machine learning background at all, such that they can take a bunch of customer reviews which are written by people expecting to be read by people, with spelling mistakes, with strange ways of saying things in different languages, stuff like that. And we make them machine readable, but in a way that kind of reflects the understanding of whatever a customer service professional or something would understand reading them. So we allow those people who are experts in the subject matter to train the model, and it means that the model has the same understanding that they would, not just kind of a general understanding of stuff, because if you work in a specific industry like insurance or travel or something, you need the model to have the understanding of that industry. And then once it's machine readable, they can do all sorts of stuff with it. They can automate processes, they can gather business intelligence, they can kind of do what they want. What does it look like? I'll rush through this, but these are just some quick pictures, which just, the reason I'm showing this is to give you an example of the sort of concerns that we have in the web app. You can see some labels that have been applied to some pieces of text here, which look like emails about travel. We have the concept of kind of confidence there. We've got some entities, so things like a departing airport and various other stuff like dates and so on. We've got things like email addresses. We've got these concepts. The key thing is we have these concepts which are used both in kind of training and in evaluating the data. And the next page, we have some validation scores, and we've got some kind of analysis that's coming out to the end of it, and all of these different concepts are kind of cross-cutting concerns in terms of being things that are required to be understood by all the different sorts of all the different parts of the application. So it's kind of a big macro front end with lots of shared concerns, and so managing it well is a major and very important job for us to be able to kind of build it in a bug-free and maintainable way. So who am I? Very briefly, I'm the front-end lead. I was the first employee. There were 3 machine learning stroke system engineering founders who hired me, because on the machine learning and system side, things were looking great, and on the front-end side, they were looking a bit lean. Fortunately, there's now lots of more of us, so there's loads of good ideas, and the product is really going from strength to strength. I should also say, just before I move on to the TypeScript bit, don't worry, I'm now getting to TypeScript, but we're full speed ahead for a Series A in summer. We will certainly be hiring once that's done. We are, however, also welcome speculative interest, so look us up, reinfer.io, if you think any of that sounds interesting, and bear us in mind for the future. So TypeScript, when we adopted TypeScript in our front end, which started about 5 years ago, the beginning of 2017, it was a bit of an esoteric choice to base the entire front end on TypeScript. That's obviously not the case now. This is a random chart I just picked off the internet, but the growth of TypeScript has been enormous. It's quite unusual, I think, these days to see a really major project not rely on TypeScript. The thought of going back to building a big front end without type safety is actually quite scary to me. Fortunately, I was employed by some systems engineers, and the idea of doing anything without type safety for them was scary. So they were like, let's use TypeScript from the word go, and we have, and certainly not regretted it. Why, and this is a really kind of reductive example, but I think I'm probably speaking to a bunch of people who are already convinced of the merits of TypeScript on some level. But you know, if you want to times something by 2, you want to take a number and return a number, and then if you try to times a delicious cake by 2, unfortunately, it's not going to work much as you'd like it to. And really, you'd rather know that at compile time rather than run time. You don't want a client telling you, well, I tried to times a delicious cake by 2 and it didn't work. You want to know that before you ever present the code to a user, and that's where TypeScript comes in. It's ahead of time type checking to make sure that your code is watertight in that respect. That's, like I say, a really reductive example, but you can pretty much in one line find a more realistic example. I certainly speak for myself when I say that I have made this sort of mistake, oh God knows how many times during my career, but you're writing a function to get the first name from an array of name strings, and so you think, great, well, I'll sort them and I'll pull off the first one and return that. But of course, the array.sort method in JavaScript not only returns a sorted array, it also sorts the array in place. And so this is no longer a pure function, it has side effects. That's probably not what you want. It could potentially cause a really tricky bug to isolate, and TypeScript comes to your rescue because you've called it to read only array, and as soon as you try to mutate it, TypeScript is going to say, no, you can't do that, which is great because it means that you prevent the bug entering your code. So that's just a bit of background. Moving on to I thought I'll come up with 10 tips that I think are really important. I've come up with 9, I'm afraid. I kind of ran out after that, but hopefully there's something interesting for everybody here. So the first thing is never is your friend. I think that certainly for me, when I first started learning about type systems, never was kind of quite a mysterious concept. This idea of a bottom type, it's really just the equivalent of kind of 0 in a number system. If you've excluded everything else, then the type of something is never. If all of the possible types have been excluded, the type of something is never. And that can be really useful in your code base in terms of ensuring that all the required cases have been dealt with. Here's a really simple example. You can write a function called unreachable, which the idea of it is that it should never be called in your code base. You put it in your code base, but you never expect it to be called. If it is called, you throw an error, great. But in actual fact, the value that is passed to it has to be of type never, which means that there's no concrete type which is valid to be passed in. And here's an example of using that. You have a type which is an animal, and it could be a dog, a cat, or a horse. These are just strings. And then you want to write a function to get the animal's sound. And the function takes an animal, and then there's a switch statement. And if it's a dog that's been passed in, you return woof. There's a cat that's been passed and you return meow. And in the default case, you call this unreachable function, and you pass it to the animal, because the idea is you've dealt with all of the animal cases. Now, in this example, obviously you haven't dealt with a horse, and so you get a type error straight away where it says, well, the type of animal is horse, because you've excluded dog or cat, so it could only be horse, but you want to have excluded everything before you reach this unreachable invocation. That's really, really trivial, but if you imagine that your code base gets big and you have lots of cross-cutting concerns and you can't co-locate, get sound method, which is actually more complex and has other bits and pieces involved in it, you can't co-locate that with animal, then at some point in the future you or another developer might think, oh, great, we've got a new available animal, it's rabbit. Add it to the union here, and then they don't deal with it in somewhere that it needs to be dealt with. Well, this is great because it means you get a type error immediately as soon as they do that, telling them, well, I'm not going to work, you need to fix me before you can move on, rather than finding out by trying to get the sound of a rabbit. I'm not sure what that is, actually, come to think of it, but trying and then finding that that completely fails. There are other ways of dealing with this, like I can't remember what the TypeScript compile flag is, no explicit undefined. No implicit undefined, something like that, anyway. But I think it's very good to be explicit about what you're trying to achieve here. And anyway, never is, having a good understanding of never, I think, is more important in a broader context. I'm afraid tip 2 is also that never really is your friend. And because there are more esoteric examples, certainly in our code base, where we want to use never to make sure that we're doing all of the right things. It's really hard to distill this down into something that can appear on a slide, but I've done my best. You can define a generic called never check, which takes a generic argument, which extends never, and that basically means it is never. It's like timesing something by 0. It basically means that whatever you put in the never check has to be never. And again, you've got this animal type, but for some reason you can't make something like a record, which will make it very easy to ensure that you've got all the animal types dealt with. You've got an array of different configs, and within these configs, you want to have at least one for every animal. So you've got a cat config that tells you it's small, a dog config that's medium sized, and a horse config that's big. Here it's much more difficult to kind of guarantee naively that you have a config for all of your animals, but you can use this never check to do that. And this possibly looks a bit daunting to initially, but it's probably not that complicated. The actual constant definition is, this is just to make the linter shut up. You're defining a variable that's just underscore, and you're setting the value to 0 as never. That's, like I say, that's just for the linter. The important bit is inside never check. And the key thing is that this statement in the middle line should evaluate, well, it's not a statement, it's a type in the middle line, should evaluate to never. And what you're saying is, I want to exclude from animal, which is dog or cat or horse. I want to take all of the configs individually, so all of the configs by index, and take the animal key, so that's cat or dog or horse. So you're excluding from dog or cat or horse, cat or dog or horse, and so the resulting type is never. And this is going to type check, everything looks fine. If you added a new animal, like a rabbit, to the animal type, then this will no longer type check. And even though your the shape of your config doesn't really match what you would often expect in like a kind of configuration, if you have something slightly more esoteric going on, and like I say, there are quite a number of examples of this that we've been kind of forced into by using a certain library or something like that in our application. You're still able to check that you are complete in terms of having all the config, which is minimally useful on day 1, but on day kind of 300, 500, 800, 2.5 years later, when somebody adds an animal and has never even seen the rest of this code, it's great that you've got something that can say to them, sorry, there's a problem. Even if you don't understand the problem, you're going to have to ask somebody, because this code is not going to compile. That's what you want. You want things to break in advance of ever giving it to a client. So yeah, never is really, really useful for this sort of thing. Third thing is about discriminated unions, which I think people are kind of quite familiar with, but after 5 years of TypeScript, I think that they're still kind of underused, and you see people do things a different way, and almost always discriminated union is so well supported out of the box and so easy to work with that it's the right way. We have times in the past where we've tried to do things like having optional or nullable types and nullable properties, and trying to work out what flavor of something a certain type is based on those, and that's always messier. Discriminated unions are great, but they're not perfect, as I'll describe. So just to give you a quick example, in case you're not familiar, if we have two types here, cat and dog, and the type of a pet is a cat or a dog, the discriminated union is just something where each of these types is an interface which has a property with a key that exists with a specific value for each of the subtypes. So here, a cat, the key is animal, a cat's animal key is cat, a dog's animal key is dog, and then they have some specific properties beyond that. So a cat has a whisker length, a dog has a wag frequency, so they kind of differ in that respect. And then you can do nice stuff like say, well, I'm going to write a function which gets the pet's whisker length. And assuming the pet only has whiskers if it's a cat, I'm not a dog expert, so apologies if some dogs do have whiskers, whatever. What you're going to say here is, if the pet.animal is cat, then return me the pet's whisker length, or just return me to 0 because we assume it doesn't have any whiskers. And this works perfectly in TypeScript because the TypeScript can infer that since the pet.animal is cat, it must be a cat that you're dealing with. And that means it has got a whisker length. It's not going to complain and say, well, it might be a dog, so it might not have a whisker length. It does, because you've already narrowed the type very, very efficiently here using the discriminated union. That's fantastic, and in a more complex example can be really, really powerful in terms of allowing you to very efficiently, with kind of quite a small amount of code, efficiently and reliably narrow the type to something that you actually want to be dealing with in a function like this. The reason I say it's not perfect, and this is something that you maybe it's worth knowing in advance, is that it doesn't work, that there are times when it fails. So it doesn't work kind of transitively, I suppose is the way I describe this. Let's say now that you have friends and you've got either a friend with a cat or a friend with a dog, and the friend with the cat has a pet, which is a cat. It's also got some furniture scratches that it's having to cope with. Or you've got a friend with a dog, which is a dog, and this friend has to take a certain number of walks per day. And your friend is one of these two. And so you're going to write another function, which is very similar, really. It's friend walks per day. And what you're trying to do is say, well, if your friend's a friend with a dog, just tell me how many walks per day they take the dog for. If it's their pet is a cat, then let's assume they don't take it for any walks because they're not one of those slightly odd people that live in a like 20th story apartment and they have to kind of put a harness on and take it to the park. So if friends.pet.animal is dog, then just return the friend's walks per day. Otherwise, return 0. And this doesn't work because even though TypeScript is able automatically to type narrow the friend.pet to a dog in this example, even though a friend can only be a friend with cat or friend with dog, and only a friend with dog has a pet of type dog, it is unable to automatically infer that your friend must be a friend with dog. It's still, in this line 29, it still thinks that friend is either friend with cat or friend with dog. And that, I think that's just a limitation that TypeScript placed to kind of limit the, to essentially provide one level of discriminated union such that the type checking is therefore not slowed down by having to check for multiple levels of this sort of thing. But it does mean that if you think that you're building a structure which is going to use discriminated unions within a key of a larger interface, that might not work for your use case. There are other ways around this. Maybe you need generics, maybe you just need to write your own type guard. A type guard would work really well. If you're not familiar with them, look them up, they're really, really useful. So type guard would make this, again, very easy. You'd be able to identify a friend with a dog from their pet. But I would only do that and not fall back on not go for a native discriminated union unless you can, because discriminated unions, once again, are great. So tip 4, this is something that has happened, I'm sure, to many people. You have some poorly typed library that you're using where it provides TypeScript types for just the stuff that it absolutely has to, like complex function that you're importing. And you think, well, surely in any sane world, they would also export a type for the parameters that complex function takes and the return type, because I want to use those in my code base. But unfortunately, it doesn't. Well, in the simple case, it's actually really, really easy to get these. You can just use these utility generics that TypeScript provides to get the parameters for the complex function, to get the return type of the complex function, and then do what you want with these in your code. If, you know, for example, you need to take them in a function that's then passed through to complex function, you need to get something that conforms to the parameters. This makes it really easy. The final point is that, unfortunately, this doesn't work very well for generics. If complex function is generic and you want to capture that somehow in the param type or the return type, there is a partial solution. It's a bit messier. I'd be happy to explain it. I don't want to go into it now. Other people may well have better solutions than I've got. Mine only really works for return type. And yeah, like I say, it may be that other people have much better solutions than I do. Yeah, if there's no generics involved, then this works really well. If there are, you have to kind of do some fancy dancing to try to get the best out of it. And so yeah, using infer for more complex cases is another really, really useful thing to master, which again looked scary the first time I saw it, but really isn't. This is a great way of kind of pulling out the types of type arguments that have been passed to generics. So in this case, you have an important library which exports a class component, a React class component, and you know, class components are kind of fairly complex things. They're parameterized with props and state, and you just want to get the props from the class component, which inexplicably aren't exported from the important library. Well, you can use infer for that, and it's super powerful. All you do is you say, well, if a class component extends React.component, which you kind of know it does, then I want you to, you say, if it extends React component with this inferred prop type P, and then anything for the state, that's fine, you don't care about that, then make the type of props P. If it doesn't extend React component, then make props type never, and it's going to break everything, which is great, because you obviously got a fundamental failure to understand what a class component is in the first place, and you don't want anything to work at that point. But if it is a React component, it's quite easy to pull out the prop type and assign it to a type of your choosing. And then again, you can go on and use it, and you know, maybe use that in the arguments for a function that is then rendering a class component. Excuse me, I'm just going to have a sip of water. So 6, yeah, enums are a broad church. This is kind of an interesting one. This definitely isn't a trick, but this is just something that I think is really useful to understand up front. Enums are this kind of weird thing that in a lot of other strongly typed languages like Rust or OCaml, they're totally 100% an important part of the type system, important type of the language, part of the language. But in TypeScript, there's the enums actually kind of fulfill different roles. They fulfill the pure typed role in some cases, and I'll get to that in a second, but a naive enum defined like this, like animal 1, is actually also a runtime object. So it's not just something that you're kind of bolting on as a type annotation, it's actually something that has a runtime value. And the runtime values are also not as easy to understand as you'd necessarily expect. So if you define an enum like this, and you give the enum values, so I suppose the different values of the enum, if you make them correspond to number values, then if you look at the object keys of the runtime object that's generated the result, it actually has a two-way mapping. So 0 maps to dog, dog maps to 0, 1 maps to cat, cat maps to 1, 2 maps to horse, horse maps to 2. You get this two-way mapping, which means that if you want to do something with the object, it's quite useful to do a two-way lookup. But if you just, for example, want to get the actual values of the enum or the keys of the enum, you have to do some kind of messiness in terms of working out whether things look like numbers or not. And I don't really particularly like it. By the way, this exactly the same happens if you don't supply any numbers when you're defining the enum. If you just let TypeScript enumerate it itself, it would apply these numbers and work exactly the same. The only difference here is that you could make dog 1, cat 2, and horse 3, or whatever, give them whatever numbers you want. Enum 2 looks really similar, but actually what comes out at the end is a bit different. So again, we have a runtime object here, but it's only a one-way mapping. It only maps from dog to 0, cat to 1, and horse to 2. Maybe that's less useful, but it's also, well, in some capacities, it might be less useful if you want to do a two-way lookup, but it also might be a lot more useful if you just want the object key. So you want to know what the different enum values are, or you want to know what values they correspond to, you could use object.values. For me, this is much more, much nicer if you do want a runtime object. But the thing about these two that I find extremely disconcerting and makes me want to avoid ever calling object keys on an enum is that this smells very much like an implementation detail. The very fact that you get different things out when you call object.keys suggests, and that's not really well documented in the TypeScript documentation, suggests that, who knows, maybe this could change in a future version of TypeScript. Maybe they decide that doing things the first way isn't sensible and they want to do everything the second way, maybe vice versa. Just looking at the way that these things work makes me kind of uneasy and not want to rely on the fact that the enums that you generate, that you create this way, have a runtime value, and maybe go down the route of making a const enum, which is very different because this is just a type annotation. What it does is it substitutes anytime that you use animal3.dog, it will just substitute the value 0. Anytime that you use animal3.horse, it will just substitute the value 2. So it will kind of go through your code base, deleting these references to animal3 and replacing them with the value. And that means that at runtime, there is absolutely no reference anywhere to animal3. It doesn't exist. It means that you can never do object.keys animal3. That's not something that's allowed because there is no runtime value. So you lose some of that power. But I feel much more comfortable not relying on an implementation detail. And if I do need object.keys animal3, why not define a kind of co-located with this enum a type called animal3 keys, which is either dog, cat, or horse. Obviously, you then have to maintain that yourself, but I think that's nicer than like I say, relying on the implementation detail in either 1 or 2 and having a runtime value. Whichever you think is better, and I'm sure many people have other opinions on this, it is just worth being aware that enums are kind of at least 3 really quite different things depending on the way that you use them. So 7, I'm sure, I hope most people are doing this, split type checking and transpilation. Originally, TSC was the only way to both type check and transpile TypeScript. That's not the case anymore. You can run TSC and give it the no emit flag, which means that it's just going to type check your code. It's not going to give you anything at the end of it. It's just going to make sure that there are no type errors. Whilst you can run the process, which is faster, you can transpile the TypeScript into runnable JavaScript. So this isn't going to tell you if there's any type problems. It's just going to give you some code that you can run in a browser or in a node process. Use ESBuild, I've listed Babel there because it does also transpile TypeScript, but ESBuild is like way faster than anything, certainly in my experience. And you can use nice things like fork TS-checker Webpack plugin. Obviously, you're not using Webpack, I'm sure there's something else equivalent, which is a great way of, if your type checking is taking a long time, it can take, I don't know, 20, 30, 40 seconds. You can prevent that from getting in the way of hot module replacements or something like that. You can make your web browser reload really quickly, even though the type checking is going to take another 30 seconds, because these are in completely different processes. You can transpile in one process, run that code, and then worry about if you've got type errors 30 seconds later when TSC tells you. All of this is in advance, hopefully, of getting a really fast, full-featured type checker that isn't TSC. There's somebody called KDY1Dev, who I think is being sponsored by Vercel to build one in Go. And he definitely seems to know what he's doing, certainly way better than me. So yeah, I've kind of got my fingers crossed there's going to be an announcement that there's at least an alpha that's full featured to have a go with. Because yes, if we could really speed up type checking in the way that ESBuild has sped up transpilation, then that's going to be fantastic for TypeScript adoption and existing users of TypeScript. But regardless of what you're doing, splitting type checking and transpilation really will make your life a lot easier, particularly as your code base gets big. You can make TSC type checking quicker though. There are things you can do to save yourself some cycles. I'd really recommend reading the performance wiki and the TypeScript repo, ideally kind of as soon as possible into your project, so that you at least kind of have in mind things that they say, this is quicker than this, and this is quicker than this, so that when you're designing interfaces and stuff like that, you can at least have that in mind. you don't always want to do things the way that are the most efficient for the type checker, but at least if you know which way is most efficient for the type checker, it gives you an opportunity to do things the best way. And you can actually opt out of that if you want. And there's loads of other tips in there about kind of how to like keep some surveillance in terms of what's being type checked, i.e. type checking a load of modules that you kind of assume are correct anyway because they're pulled from libraries. There is also this generate trace flag, which is actually really, really useful as well to avoid kind of guessing where bottlenecks are. It's worth running on a big code base to see is in actual fact 40% of your type checking in this one file, in which case clearly there's something that you can do to improve that. If you're just doing loads of work all over the place, maybe it doesn't give you much value, but it's really, really, if you're struggling with type checking speed, it's really worth running a trace to see if there are significant bottlenecks. And then at least you can kind of experiment to see if you can improve those, because like 10 seconds saved on every recompile is like it adds up really quickly. And the final thing, and this might be controversial, other people might have really different opinions on this, but I really like this ESLint rule, consistent type imports, and I'll explain why. What this does, it forces you rather to import type when you're only using an import as a type. And so for some things, types, interfaces, you only ever use them as a type because that's all they are. For other things, enums I mentioned, classes, these have runtime values, but they also have, they're also useful as types. If you force yourself, ideally using this ESLint rule, to always import type when you're importing a type, it means that you can immediately assume that those lines will be stripped out very kind of trivially when you're actually transpiling your code, because the types don't exist in JavaScript. Why is that useful? Well, circular runtime dependencies won't work in ES6. They're kind of not supported in the spec. There's, depending on the actual way your code works, there's kind of ways that you can import stuff circularly and still have your code run, but it's, you know, in general, it's to be avoided, I would argue. And you can get these really, really awful problems that are extremely mysterious, where all of a sudden your kind of code transpiles apparently with no problems, you have no type errors, and then you run your code and the value of something is undefined that when you're expecting it to be defined, and there's no obvious reason why it's undefined, and it turns out it's because of a circular dependency, so something a module hasn't had time to initialize before it's been referenced by another module. And that's really bad. These are really horrible problems to solve. But the last thing you want when you're solving them is to have like a bunch of spurious circular dependencies. We use a tool called Madge, which I found really helpful in terms of identifying and removing circular dependencies, particularly because they can be kind of silent. You want to strip out these false positives. There's nothing worse than running a tool to find out, well, where is my circular dependency? Where are my circular dependencies? And it says, oh, right, you've got 178 of them. In actual fact, a lot of them are simply because you're importing a type or two from a TypeScript file, which then naively, Madge or whatever the tool is, assumes means that you need all of the JavaScript in that file initialized before it can be used, and so it's going to create circular dependency problems, when in actual fact all you're doing is importing types, and that will have no runtime impact at all. So if you use this ESLint rule, there's a flag in Madge that basically says ignore types, and it means that you can really focus on what these problems are, and that becomes much, much easier to do if you kind of do this from the start. If you force yourself to use consistent type imports from the word go, it means that when you do have problems, it's much easier to kind of identify non-type based problems when they arise. I think it's possibly also quicker. I'm not 100% sure. I would have to ask somebody who has more knowledge of the TypeScript compiler than me, but again, you're giving a clear hint that you are only using something as a type, and for runtime code, it's not relevant, which absolutely can't be a bad thing. So yeah, that's the final tip. I was unable to get to number 10. So number 10 is just questions, if there are any, and we'll see how people, how broadly people disagree with the stuff that I've suggested.
Okay, so yeah, thanks for that, Richard. Yeah, brilliant presentation. So I'm just having a look now just to see if there's any questions that have come through. Just bear with me one moment. Yeah, no, I think we're all clear with the questions. There's not yeah, I think you must have covered everything. No questions there. So yeah, no, thank you for that. It's been really good having you on the live series. Really appreciate you taking your time to, do this presentation. So if anybody would like to rewatch this or pass it on to any of your friends, I will leave a link to the YouTube video on my LinkedIn post tomorrow. So be sure to, connect with me on LinkedIn and see that, and also with Richard as well. And if you do have any questions for him, you can, reach out to him directly as well. I'm sure I'll be happy to, answer your questions if you do think of any, after we finish this. But yeah, be sure to. Sorry,
yeah, apologies. I'm just going to very quickly see if I can put my email and Twitter in that last slide and have it hot reload. Hopefully, how's that going to work? Because I should really done that in advance, frankly.
Okay, don't worry about it. So yeah, like I was saying, please feel free to reach out to Richard directly with any of your questions. As you can see, he's happy to help with any advice and any tips, of course. So yeah, with the live series, this will be going on the live series account on LinkedIn as well. So make sure you follow that and keep up to date with all of our webinars. It's the first of 2022, so but it's definitely not going to be the last one. And that being said, if anybody wants to do a presentation in the future, I'm always happy to chat about topics that you'd like to discuss, just like Richard's done today. So yeah, that's everything from me. Richard, I don't know if you want to add anything now.
I just want to say thank you very much for anybody who sat through that. I hope there was something that was very interesting.
Yeah, I think there's a couple of people watching. But yeah, so yeah, that's all from me. Richard, again, thank you very much for for doing this. But yeah, everybody else that's watching, have a great evening, and thank you for joining in.
Cheers. Thank you very much.
Cheers.
Bye.